Saxon Algebra 1, Lesson 101. We're going to talk about factorable denominators in just a second. Second week of the spring session. We're on week 27, and we're going to be done soon. Okay, let me just dive in and show you what we're talking about. Example 101.1, there are 3 examples in this lesson, my favorite number. We are asked to add. Simple enough, right? But then when we look at what we're supposed to add, your brain might swoon for a minute because it's kind of wild. We have to add those 2 fractions together. I mean, technically we're subtracting, adding a negative number, however you want to look at it. Well, we know that whenever we add fractions, the denominators have to match. So somehow we have to get these denominators to match. Oh, they do not look close, do they? I mean, they both have an x and they both have a plain number, but the numbers don't match. The signs don't match. We know that the only way we can change a denominator is by multiplying, right? We can't add to these numbers. So it looks like a bit of a mess until we think to ourselves, this looks factorable. What if we factored this? That's the clue. Look, factorable denominators. John's so clever with these titles. We know how to factor something like this, right? We look for 2 numbers that multiply to this and add to that. Go ahead and think for a second of what they might be. Right? They multiply to -12 and they add to -1. Beautiful. We factored them. I'm going to lightly squiggle that out so it doesn't distract me. Now we see, oh, this part of them matches, right? The x minus 4 part matches. All we need to do is multiply this second fraction by the same thing. Here, let me write it out. The least common multiple will be x minus 4, x plus 3. We've already got part of it. I'm going to put parentheses around it just so that it's safe. And what we'll do is we'll multiply this second fraction, just like we adjust regular fractions by multiplying them. We'll multiply top and bottom by that piece. And now this looks just like, oh wait, my bad. Plus 3, not minus 3. You were wondering, what is she doing? Now it matches, doesn't it? The denominators match. All is well. Now we can turn our attention. Oh, excuse me. I'm yawning today. Now we can turn our attention to the numerators. It'll be 6x minus p times the quantity x plus 3. The denominator is perfect. I'm not going to write that because we need to fix the numerator before we finish it up. It'll be 6x minus px, right? Minus px minus 3p. And we scan those to see if there are any like terms, and there are not. So now we can put the denominator back under it. And I like to see the denominator left in its factored form. This is perfect. If you left it in this form, I would probably tell you, keep going, you're not quite there yet. This is the right answer. Yay! So, all we have to do in these problems that's different is we have to deal with big crazy factors. I'm sorry, that's not right. We have big crazy denominators that need to be factored. Right? I should point it to that one. But we had to factor that, and then we were able to create an LCM and adjust the other fraction. Let's try another one. This is a great example of a lesson where John's taking something that we already know how to do, factor trinomials, and he's giving us a chance to use that as a tool in a bigger problem. Here we go. All right. This one, we're going to factor both sides. We're not going to factor them the exact same way, but we're going to factor both of them. This is going to be a pair of binomials. Has to multiply to minus 6 and add to minus 5. Here's what I get. And this one, this isn't a trinomial, so we can't factor this into a pair of binomials. All we can do is pull out an x, and we're left with x minus 6. Okay, and we see, look, there's some overlap, but they each have pieces that the other one doesn't. So it really helps if you write out your LCM, because then that's the whole thing, right? I like to put the little x first. X minus 6, x plus 1. And then I like to use another color just to help me see. I'm going to multiply this one by x over x. And then that one looks good. And then this one, I need the x plus 1 piece. All right, top and bottom match. So I'm allowed to multiply that way because this equals 1 and that equals 1. So I'm not changing anything. So now I'm looking at my denominator, or my numerator only, 7x minus 5 times the quantity x plus 1. I know my denominators are fine, so I'm going to ignore them for a minute while I deal with the top. I'm going to distribute 7x minus 5x minus 5, and then I'm going to add those like terms, and we will get 2x minus 5, and then I'll put it over my whole big denominator, x minus 6, x plus 1. Yay, that's the right answer. Nice, right? Again, factoring those denominators cracks this problem right open. Let's do one more. And all that's happening in this one is our numerator is getting a little more complicated. Not the end of the world, though. This one's still nice and simple. Okay. And again, when you see this one, you'll probably have a little moment of panic. It's like, it looks weird. Why doesn't it have a plain number at the end? And you realize, oh, we're going to factor it differently. So now we're going to factor this one. Multiplies to minus 6, adds to plus 1. Take a minute and think. Did you get this? Right? And then we squiggle that out because we don't need that anymore. And then this one, all we can do is pull an x out of both terms, and then we're left with x plus 3. Sometimes these kinds of factoring situations are almost more difficult than these because we haven't done as many of them. We've done a lot of these lately, but we haven't done as many of these. So get used to those though, because we're going to continue to factor both ways for a long, long time to come. So when you see something like this, just go, oh, I can do this. It's easy. What's our LCM? Our least common multiple. we have to combine the pieces of all, right? So it'll be x, and then it'll be quantity x plus 3, and then x minus 2. And then we compare each of our existing denominators to that and figure out what do we need to make our denominator look just like the LCM. And this one, it's the x minus 2. Which I'm kind of having to squeak in there. Top and bottom makes it all work out. Now, I noticed that this is a quantity, so what's kind of helpful is to put that in parentheses. So now I'm going to do it in simple steps. X times the quantity 4x plus 2 minus 4 times the quantity x minus 2. The quantities make it a little bit trickier. We have to pay close attention, and then we have to distribute. I know the denominators are fine, so I'm just going to pay attention to the numerator right now. I'm not going to keep writing it over and over. I'm just going to look at the numerator. I'm going to have to distribute this one, and I'm going to have to distribute this one. This 4 comes with a minus sign, so I'm going to be careful of that. So I get 4x squared plus 2x minus 4x plus 8, right? The two minuses make a plus. 4 times 2 is 8. All right. I can add some like terms. 4x squared minus 2x plus 8. That's as far as we can take it. We could factor a 2 out of every term, but it's okay. We can leave it like this. And our denominator, rather, oh boy, I cannot say the right word today, can I? The bottom, we fixed way back here so that we can just copy. And there is our final answer. All simplified and reduced, real pretty like. Yay! That is lesson 101. We will be using these skills for a long time to come, and we will come back to this lesson early next year in Algebra 2 and review this. John is taking this opportunity to kind of plant the seeds of this idea into your brain so that next year it'll feel a lot easier. Okay, thank you. Goodbye.